Welcome back. So today's video comes in response to a question from Songsan Chen at the University of Vienna. And he asked how he could work with the files that contain the abundance from the unigenes in GMGC, given that they are so large. And this is actually not a specifically GMGC question. It's more about how do you handle these very large tables, and we'll show you in a second how large they are. And here I'll be showing you how to do it using Python and Pandas, and this is a solution that you can use in many other problems. So this will make a little bit more sense if you've seen our previous video on how we get mags from the GMGC, because at the start it's exactly the same. So in this case, I've already pre-downloaded the data using git annex. So in this GMGC 10.data directory, and here I've gotten two files in particular. So the first one is this card resfam data, which is the antibiotic resistance gene annotations for unigenes. So this is a table. So the first few lines are comments, so with the hash sign, and then here, so unigene 25 has been annotated as being an MSPA antibiotic resistance gene, and there's also these arrow annotations, and there's a little bit more information. But here, what we want to do just today, or all we want to do today, is get from the abundance table, we are going to get the abundance just for these ones, and let's just count them just to get a feeling for how big this is. So remember, we have 300 million unigenes in total, and apparently out of these, about 3 million are antibiotic resistant. So it's about 1%. The next table we want to use is this abundance table. So again, very standard table. We have unigene sample. So this is a sort of sparse matrix. So unigene sample, and then a few different measures of the abundance. And so if you just want to pick one, maybe pick the last one, norm 10M, which within a single sample sums to 10 million being normalized. So if you want to pick one, pick that one as relative abundance, and you can check the documentation for all of the other ones. So this is a much larger table. So here you can see that it's a sparse table. So anything where it was a 0, so if this particular sample did not contain a particular unigene, then it's not going to be listed. But still, it's a very large file. So let's just check real quick here. We have to read the link, a little bit of trickery, but it's 369 gigabytes. This is also why I pre-downloaded it instead of doing it live, because it does take a while, even in a fast internet connection. All right, so let's use Python here to do this. And so the first thing we're going to do is, and we're going to load the set of identifiers of all of the genes that are annotated as antibiotic resistant. So we just have to open this file, this resfam, and we're going to ignore all of the ones with the hash sign at the beginning, and then just get the IDs. So we're just interested in the IDs here. And let's see, just check, spot checking. Yep, 3 million here. And if we look at the exact number, we've lost 2 lines, which are exactly these 2 lines at the top with a comment. So everything looks good so far. All right, now let's load the table, and we cannot load the full table. That's exactly the problem. Otherwise this would be completely trivial. And this is the flavor of a lot of the problems that we have on a day-to-day basis, is that we want to do things that are conceptually very, very simple. So here's a big table, just get the rows with these identifiers. But because the data is so large, it actually takes some thinking, and it takes some engineering to do it. Whereas if the table was a few 100,000 lines, this would be 2 lines of Pandas, and it would run in 2 seconds. But once you multiply the data sizes by we're handling big data, then things become a little bit more complex. So this is what we're doing here today. So we've just loaded 12,000 lines. Let's just check. Yep, it looks good, exactly what you would expect. So and now let's select the lines here that match our interesting set. And so the way we're going to do this, we're going to use interesting dot underscore contains underscore. So this is a built-in thing from the set, and where it's going to do this operation, like in the command, the Python command line, if you write something in something, it does this contains operation. And this is also why we're using a set, because a set contains operation is very, very fast. We would say it's an O of 1 in the sense that even as the set grows, this operation is still very fast. Whereas with a list, if you have a list that's twice as large, this operation takes twice as long, whereas that's not true with a set. So here, by applying this contains operation to each individual index, we get false, or mostly false, as we can see, but sometimes there will be some truths in there, and we can use this Boolean array, so this array of truths and false, as an index into the chunk itself. So here, let's just check, and yes, it does work, and we have 191 rows. So remember, we had 12,000. We had this rough idea that about 1%, we should keep about 1%. So it's a little bit more, but it's the right order of magnitude. So things do look good. All right. So this is the basic operation. Now we just need to, instead of just doing the first 12,000 rows, just do chunks so that we go over the whole file. So here, first we need to just open this output file, and we're going to JZip it just because, even this selection is still going to be pretty big, so it's still worthwhile compressing it. And then we are going to be using again the read table, and now passing it this argument chunk size, which enables us to, instead of loading the whole thing, it's going to load chunks of, in this case, 100,000 lines at a time. Then we select the lines that matter. Here, just, if it happens that in a particular chunk nothing was selected, then we ignore it. And then otherwise we write out the TSV file. So here we want the separator to be a tab. And here you can also see why we needed this first write variable, because the first time we write it out, we do want to keep that header, and then subsequent writes, we will no longer write the header. So this is it. This does take a little bit of time, so we're not going to see it to run all the way here today. But let's just check that it is indeed doing something. Let's see. Yep. Let's leave it running in the background. Oh, yep. That file selected that appeared. There it is. We can just have a peek to see if it looks good. Yep. It looks the same format as the big file, except it's now only a selection of the rows we want. So yeah, there it is. And we can see, let's see, yep, it grew a little bit in this few seconds I've been talking. So that's a good sign things are happening in the background. So just as, if you think about it again as a rule of thumb, so we started with 369 G. So if we have 1% of that, we should have, maybe, 3 something G. Now if we try to think about, okay, maybe there's some compression, etc., but that would be the order of magnitude, somewhere in the single digits gigabytes. So this will take a while, but it will finish. And then you'll have a table that's much smaller and maybe much easier to handle. And from then on, you can do your processing. So if you have any questions about this or about any other questions, so for GMGC in particular, we have a mailing list. So that's actually the most appropriate place to ask questions. But just email us, show up on Discord. Please subscribe to the channel, and I will hope to see you soon.